this one work?
You get tired.
Look at me go.
That one fits these little mounts, and these are adjustable. So this hole is for the standard size, I think, and then these ones are for the motor module, which is a little bit longer.
Right. So did you ever grab that? Is everyone here? You just unbolt it and scoot it down, and that's so you get the right length so you can hold it. So it's off the table so you can spin it and everything else. And we did. This is probably under here. We did several iterations of these holders to get it so that was actually the degrees of freedom we actually wanted. So it turns out that it is helpful to spin it when you're doing the layup process just by nature of working on it. And you sometimes have one person spin it and one person using their hands to smooth something onto it, like I'm winding it on. But it's very important that they're bolted down so they don't go this way and they don't go this way. So it's the translations are an issue. And they also, it has a lip here, so it can't go that way. So this is not like by accident that that's like iteration 5. 30 minute round. Okay, so where were we going? We scoot these into the resolution. Prep. Oh god, prep. Okay, so yeah. So step 1 is that everything is wildly clean. You got to be like medical on this shit. So you have to have your gloves going and your acetone going. Everyone is being very careful. Everything is clean. The surfaces are all clean. You're doing this like an aerospace company. You know, it's a white room. And so this probably has the gunk left over on it from the previous layup, like this did, and we never cleaned it, I guess. And this is actual glue that's left that's just stuck on there. So the step 1 is to sand this off, and so we use like steel wool and acetone, and like you have to scrub at it. I mean, it's kind of like 30 minutes of scrubbing. There might be a better way to do it, but you want to take off too much material because you want the aluminum to still be. This is a machined surface actually from one of our sponsors that did it, that got it accurately and nicely.
There are also ways of treating the tool properly that make it do this less, or even not at all. And so one thing we tested is, so first there's a cleaning agent which we just use acetone most of the time, works fine.
This is strong acetone.
And you clean it like 4 or 5 times until like a paper towel is perfectly clean, and then you put this wax on it, and so you'll saturate like a rag or a paper towel and wipe it on until it's like a thin layer, and then let it dry, and then like wipe it clean again.
Buff it off, yeah.
Buff it, and then you'll do that a bunch more times.
Like 4 more times.
We tried doing it like 10 times or 3 times, and we found the more you do, the easier it is to get off. But it never was perfect, so that would be something to improve if you can, just figure out how to get the tool.
A better mold release system is something I would add to your guys' list.
This is for sure like retail stuff.
And they come in a system. This is this Orcaskin system. So.
Right, so it's like a step-by-step thing.
Right, and the instructions are on this, and also the instructions are all on the online documentation. Everything is written down, the methodologies of testing, everything we did is on there, so you can learn that. So you're going to put wax on, then you're going to wax off, and then wax on, then wax off, and wax on, wax off. And we're talking like it's an exorbitant amount of work if you're sweating around here, spending an hour per mold working on this, and people are doing other things. And by the time you get the last wax off, then you put it down and you don't touch it. And so then you have, in parallel to that, have somebody starting treatment of the rings. And so the treatment of the rings is anywhere that you're going to bond carbon fiber to it, you have to take off the oxide and treat it such that the carbon fiber and the aluminum don't corrode. What's the corrosion called again? Galvanically corrode, because they're at opposites of the galvanic scale. So 3M and company invented this magic treatment death material, and you grab it out of the bag that it comes in, and you mix together the 4 parts and the ingredients the way you do it, and you shake it in the bottles and whatever else, and you take it, and you sand off the area you're going to be putting the treatment on.
So we're bonding the first ply to this layer, and then the outside ply gets bonded to this little shoulder.
Right. Those 2 surfaces, and not the inside.
We did actually, though, we did have issues where the resin would leak through this, between the tool and this.
Yep.
And so we treated this surface with wax.
Right.
Released.
Okay. So you have to be really careful that you wax the places where you don't want it to stick and add this stuff where you do want it to stick, because this will make it stick.
And so this is kind of a complicated process. I mean, it's not that complicated, but it's time sensitive too.
Right.
And it expires after like
a day.
But we use it a bunch of times.
And it was
over
always
the course
successful.
of like
It
a
was
week or a
fine.
month. And
Okay.
I mean, it was fine. I don't know how long that lasts, or
Anytime
it
you
should
see,
probably be tested. But
anytime you see aluminum that's bonneted that looks like this, it looks high quality and strong and everything else, it's done with this system. So it's stayed this long and it's still strong.
yeah.
But also that thing expires the little jar in a day, or
Yeah.
2 days or whatever.
And there's actually it was that
Yeah.
document I was just holding. No, it has a in plastic.
Oh, I just saw it.
Right.
The 3M one?
Yeah, it's all this is right here. So that has everything about this. And that has, is it several coats too? Or it's just the one?
No, several, I think.
So again, you have to sand it to clear the oxide layer first, then clean the shit out of it, and then apply this.
Okay.
So you can imagine what you're looking at is like when you take the wipe and you wipe it clean, like the aluminum like changes color when you clean with acetone because it's so perfectly clean, and you're on perfect new napkin sitting out wearing gloves that are brand new and clean. Everything's clean. And then you soak it in this thing, like Sam was saying. Sam was always the one that did this. You soak it in it, you let it sit on there for like 20 minutes, and then you wipe it off. And then I think you put another layer on, and then you let it sit, or you wipe it off, and then you don't touch it. And then the rings are ready. So they're waxed on all the sides. They're going to get glue on them, and they're treated and sanded and cleaned, and ready to go on the other side. Okay, and then you take the 2 rings, and you make sure you put them on correctly, and you put them on the mandrel. And there's that.
Which is
There you go. And you see that there's holes. So,
And the reason we did that
is
was of this.
so. Were you saying something, Con?
No, I don't remember some of these things. It's been a little while.
It has been a hot minute.
So these mate to the rings to keep them oriented correctly, straight, and so they don't move when everything expands and everything. And we
This
even
wasn't a pain in the ass last time.
the aluminum expands a ton in heat.
Alright,
And
well that's stuck, so
we actually
you guys
had
get that off.
we had one case where the expansion was such that we sheared off the bolts that held everything together.
Right.
So like it expands a lot, like significantly.
Right. So part of the point is that you see on these rings that there's, where's the ring?
Which one?
Any of them? Yeah, you see that there's these towers here, and then there's this really thin 30,000th thick section here. Well, we realized in our analysis that all this extra material that was there before we machined it all out was too much extra, so we tried to lighten this because this is going to be used, at every joint in the rocket. So if you lose a gram off this, you could lose 15 grams off the rocket or 20 grams off the rocket, something like that. So we took a lot of material out. So it's machined here, which means that these posts is what we call them, are kind of where the strength is. So if this post isn't aligned with the next post and they're not clocked, then you're kind of loading it stupidly. You're not loading it like axial along the fibers. And that is okay, but it's not perfect. And this 30,000th wall isn't that strong, but it also is pretty damn strong. So you put this on here, like I fucked it up, and it's not that hard to get on there. I just kind of screwed up because I wasn't paying attention.
Hand
But-
tight.
Hand tight, impossible. So you slide this on here, and you bolt the ring to this thing with the same screws you're going to attach to the stainless screws, and then you bolt this thing to the molds, and you do the same thing on the other side. And there's a female and a male one of these. And so now you have your rings bolted onto your mandrel. Everything is prepped. Everything's happy. Everything's stuck in the right place, and nothing's going to move while it's curing. No nothing. Okay. And the reason that this is so thick is so you can put extra wrapping on it. The shrink wrap, so you can go further off the part before you tape it down. So learn from this part. This is a multi-iteration part also.
The tape, we'll talk about that later, but the tape really doesn't like changing diameter.
Yeah.
It's not very flexible, so you can't, like if you wrapped it all the way around and then had to like jump down to this, it would be horrible. And it doesn't work.
It's really unhappy.
So we would wrap it and then terminate it at the end of this with thermal tape. That's the blue stuff I was talking about. And it's just high temperature tape. Anything else is going to melt.
Right.
So you're going to need some of that, and that's on the VOM too.
Okay, so at this point then, somebody at this point has already gone through and gotten all the templates out and got the carbon fiber, the adhesive and the core, all of the pieces cut and in piles.
You mentioned this to somebody else, but pay attention to the direction that you cut this, because if you cut it in the wrong direction, it won't wrap around.
You see, it literally won't wrap in a circle this way.
Yeah, it's not possible. So
It'll-
just make sure when you cut it out, the orientation is such that it wraps.
Perfect. So you have all your pieces, and that includes the glue strips that go directly underneath this first layer here, or the second layer there. So like the little strips, and everything's all put out and all in an organized stack, and you have your thing in the jig and everything ready to go.
What strips?
Adhesive strips.
Yeah, so the way that we did the adhesive is that you need the first layer goes over the entire surface and terminates on these surfaces, but then on the outside,
Go on. Sorry.
what are the strips for?
They go
on
over
the,
here.
The outside still terminates though.
No, so imagine that you put your first layer of carbon fiber down, you're putting it over this layer. Well, if there's nothing gluing this thing to the carbon fiber, then there's no stickage.
Yeah, so the glue goes down first, so you lay a strip that's exactly this size, and then the carbon goes on top. And then you do, yeah, go ahead.
I was gonna say, for clarification, that's the adhesive layer seen in the layup process.
Yep,
That's the what you're talking about?
Yellow shit.
And that goes over the ring.
So, but,
the first layer.
but what you can't see here is the one that goes between this carbon layer
That's what I'm talking about.
and this surface.
But it's that same.
Yeah, same stuff.
Gotcha.
Anywhere you're trying to attach something to carbon fiber, you put adhesive film.
Including
Every
core.
time, including core, including anything.
That
Except
was,
for
that
carbon-
was what I wasn't getting, was that it was underneath this layer.
Exactly. But
Got
it's
it.
definitely not against this layer. It's a thin strip, and be very careful when you're cutting it out that
I
it is
found it.
against that
Yeah,
layer.
by the way.
You found it?
Yeah, I just found it.
Everyone on the same page here?
Yeah.
And make sure it doesn't just like, it isn't like right up to the edge and it's perfect. No, it's like back a little bit because it flows when it glues.
Yeah.
Everyone on the same page?
So carbon fiber
Whatever
and
this,
or carbon.
this width is, we wanna go slightly
Semi-
less than
yeah.
that width.
Yeah.
Okay.
And we
Maybe
have
you
a
guys
template.
ran into
Super permanent.
You have a
Yeah,
template for
I
it?
think I saw
Wow,
a
different.
compression test. You guys ran to put some stuff out or.
Yeah, that's what these are. These are
Yeah.
for taking out. Oh, and it's a nightmare to get this out of the mold. So honestly, one of the most important things you guys could do is find a better mold release system. As like step one, like help everybody.
Yeah, because it's extremely hard to get that off.
Yeah, we
There's
have
so much surface area that even like just some sticking points is just really incredibly difficult.
We found that we use this jig, we made this tools, we'll tell you about them later, and an air hammer, and that's the best way to get out. And that's like, and like,
And we even tried putting it in the freezer to like get the aluminum to contract, and like it just is really hard.
fucking permanent bonded. But that is that. You guys work on that. Next step. So you put your adhesive films down this one and that one. So you know you're gonna put your carbon fiber down next. This is of course over here still.
And the glue is similar to the carbon in that if it gets warm, just the heat of your body,
Right.
it gets a little bit tacky.
Tiny
So
bit, yeah.
you kind of have to cut it a little bit long so it overlaps itself
Yeah.
by a half inch, and then you stick it to itself, and that's how it like stays on.
And you
'Cause
can
it-
use like your heat or your thumb.
yeah, because it doesn't stick to the aluminum when it's cold.
Now you put it on there and it'll fall off in front of you.
It's
And you
really
could,
annoying.
another tool you guys will need to buy because we used Rob's was essentially like a hair dryer but like an industrial one.
Heat.
Oh.
He can.
Heat gun. All
You
right,
can just
you guys
use
have
it
heard
for
of it.
Yeah.
It really, that's like the number one like layup tool as you're doing this is you see everybody in Formula One using it. And it's just like you heat things up with it and they become sticky and they stick together. Or else you can't wrap it around it and stick it to itself. So, you have
So
your
it's
strips
those
on
two
here.
strips first, right?
Yeah. Next step, you take your carbon fiber out and you make sure that you don't do this the wrong way. There's a pretty side and a non-pretty side to this. You can tell this is the non-pretty side. This writing. So if they would have just flipped it over, it would have been perfect looking. Don't forget to do that.
Yeah.
So you flip it over the correct direction so it doesn't have writing on the outside. You take your layer and you line up the edge, exactly perfect. And we found that trying to line it up on both sides was a disaster. And it was really just someone that's like painstakingly detail oriented like Sam. And you get him to line it up on one side and then you stick it down and you hold it down and it sticks to the metal a little bit when it's a little hotter and a little bit less expired. And then the other person slowly wraps it. You're watching just one edge over here and you're getting it so it follows the contour of this lip surface right here. And so someone's kind of like helping us turn it around and the other everybody's like getting it exactly right. And it's just one of those things you'll learn how to do as a team.
The reason to do it right the first time too is because it's impossible to fix. Once you, like you said, once you stick the carbon to itself, it's like, it's almost impossible to get it back apart without ruining it. So if you're not careful, it's like putting a sticker on, you get bubbles in it, and like you just can't get them out.
And there'll be bubbles in the
It's
center
horrible.
and you'll be like, what the fuck?
And then when you do get a bubble, after it cures, you'll get like these really nasty wavy sections in the weave because it was kind of slack.
Did you guys try rolling something onto it or anything like that?
Nope, just with your hands, if you do a careful job of it, it's really, it's not that
The
hard
other
once you get the trick of it.
trick is to use this peel stuff
Yeah.
as your tool to push it on, so it doesn't stick to your hands.
So you push on with your hands, and then if you pull your hands back off, your hands are stuck to the carbon fiber, so it's trying to pull off the carbon fiber. This stuff is, I don't know, waxy or something like that. So when you push it on this, it doesn't stick to this at all. So you can use this almost like a glove and be like, okay, I'm gonna push it down hard like this.
It's just like applying like a vinyl sticker, essentially.
Cool.
If you're careful, it's not that big a deal. So you get it all the way around, and then don't forget, for everybody who's doing their design work, that the carbon fiber has to overlap itself, or else it won't. You can't just do a butt joint with carbon fiber; it has to be overlapped. And that the overlappingness, I think it was a half inch. Oh shit, was it a half inch or an inch?
Maybe it's more than a half inch.
I think it's an inch. I think it's an inch.
You
You can quote me on it.
let's see.
If you do a 1 inch overlap, that's as strong as no joint. So anyone that's trying to do metal work goes, really? And the answer is yeah. Like if you weld two pieces of metal together, it's weaker than it was. But if you do a 1 inch overlap, it is as strong as if there was no joint. And there's no adhesive film in between the two. You just put carbon to carbon and it sticks. And so that's it. Really, it's that easy. Isn't that great? Awesome. Excellent. So you do your,
about that, that's awesome.
yeah, don't worry about that. That's an easy solve.
Core is worse.
Of course, yeah. So you go around, you do this, you use the yellow stuff as your helper, whatever else, you get it exactly along the edge, you do your 1 inch overlap, you get it sticky down. Okay, the next layer is adhesive film.
And sorry, part of that is generally with this system, with redesign it, that one person is spinning it like this the whole time, and the other person is following along with carbon.
Right.
Or
And it's not
whatever
that fast,
material it
it's
is.
like this fast.
Yeah, it's very slow. But it's sort of a two-person job at least. Someone's rotating it and the other person's applying the material.
Pick your two most detail-oriented people. That wasn't usually chosen. So, you have a carbon fiber on. Is there any more questions, any more comments about strategy on that?
Not yet.
Any questions?
Quick question on the, so you covered layup on the first ring, moving down to
So-
prevent bubbles, and then, or are you doing both edges simultaneously?
Simultaneously.
You have a
Simultaneously,
piece
so
that's as wide as this,
Got it.
and you just use one edge just because looking here and looking over there and trying to adjust it back and forth is worthless.
Trust your cut.
And your cut is exact.
Got it.
That's why it's
So-
important to use the template.
Yeah.
Just get it right up
Cover
under that
across.
lip and do a killer job of it.
So
Line up one edge and try.
both rings are already installed, both of the dummies are already installed.
And it would be horizontal while you do that.
This whole thing is here.
It's just like that.
And it's actually in these mounts, and it's perfect, and it's in these holes, and it works fucking stellar. And the bolts exist, and they're wing nuts, so they're easy to get off, like we thought about it a lot. Excellent. So the next layer is the adhesive film, and the adhesive film is a layer of like cardstock shit, and then one layer of this blue plasticky stuff, and then the white stuff in the center is your actual adhesive film. So don't take the other stuff. So when you put this down, we always pull off the backing, and then put it on top of the carbon fiber. And this one's tough, it gets bubbles, and this one's, it's unhappy and it's sticky and it's gushy and whatever else. We use the same methodology roughly, except for this one you're using the heat gun now, and that makes it stick to the carbon fiber. And so you're kind of getting it down, and if there's any wrinkles where it's over itself, you can just fold it over and squish it down nice and tight, because the glue will be mostly happy.
The glue flows when it melts.
Yeah. So you get it mostly happy, you lay down your whole thing, you go over the whole thing, and once again you have the one, like half inch, 1 inch overlap at the end of it.
And the trick to this, you mentioned a little bit, is that once you, essentially you like use the heat of your thumb to like stick it to itself or to something, and then use like your nail or like we had little tongue depressors, and just like, because it's impossible to get this stuff off, especially if you have gloves on, just like scrape at the edge and it comes off.
Yeah. Tongue depressor is like the magic tool. You do it one time and it comes right off.
Yeah.
Or else you spend 10 minutes trying to get it loose. Same, figure that out. Pretty good. So you got this whole thing stuck down, and then at the end you peel off all the blue stuff. Most of the way around you stick it to itself and you peel the blue shit away. The next layer is the hardest layer is the core. And so the core has to be stuck to the adhesive film with just its little edges, to the point where you have to be able to like push it down on something and it stays. So even when it's trying to do the anti-classic thing, the whole thing is stuck down. And so you're taking the core and you have someone going back and forth with a heat gun, and you heat it up and then you press on it with a hand for like 6 seconds until it like cools down, and then it cools down and it kind of grabs onto it and you keep going. And if it pops back up somewhere else, you can kind of keep sticking it.
So this part is like a three-person job. It's someone spinning the mandrel, someone doing the heat gun to make the glue tacky, and then the person applying this. And you want to like depress it into the glue as you go so it sticks.
But don't smush it, don't buckle it.
Yeah, don't crush it.
So use broad hands and push on.
And you'll have that problem where the ends of it flare out like a potato chip.
Right.
And you just gotta push it till it sticks.
Right. Stick
And
it.
it's really, really annoying and difficult, but you just gotta do it a bunch of times and you'll figure it out.
And then you do it all the way around, and you're of course aligning it with this edge over here. All the way around. By the time you get to the end, you have to leave extra. And this is kind of where this is the only layer that has kind of a finesse to it. And so we left like this much extra or something, or like an inch extra. And this is all written down. And the reason you take that extra is because of the part in his hand.
Yeah, so if you
don't-
just do a butt joint, like a perfect fit, it pulls apart when it cures and you get this gnarly like canyon down the middle of it.
Right.
And so you have to like compress it together at that last inch, and it doesn't look very good when you do it,
Right.
but it comes out nice.
See, it's like a little bit of a spring, and you spring it a little bit, and then you stick it to the adhesive, and it's sprung kind of like this, but it's all stuck down nicely to the butt joint, and then when it starts to go in the curing process, it comes out to the perfect joint. So you guys would never have known that there's a butt joint of adhesive foam, and I bet you can't find it. I can't find it. No one can find it. It works, and it's repeatable, and you just have to know to do the 1 inch and get it right.
And there may be an easier way to do it.
So
Maybe.
1 inch of overcut, and you're gonna say maybe ½ inch of compression on either side?
And then you just compress the one.
Just you
Yeah.
compress one side down 1 inch,
It's easier to do it that way.
Yeah.
and 1 inch over.
Rough and lunge. Look at the pictures and the design log and everything else, and it will be like exactly what we did.
Got it.
And we actually took a million photos of the compression joint we're talking about, just to show you what it looked like on every single layout. Because we had this happen where the channel happened, the valley happened, and we were so disappointed in life that we essentially took a picture of this every other time we laid up after this. So you get to see what that looks like on every one of these photos.
So I think what he was asking was, because we're doing big, we're doing 6-inch diameter and they're doing 14-inch diameter, like, would we need to compress more at a bigger diameter?
There's no science to it.
There's no sense.
You just have to do it until it works.
It's my feel. So, but this is the nature of composites, is that it is kind of a feel thing. You guys have figured out, do your documentation, and everyone will copy you from here on out.
The only thing that matters is that you compress it enough so that it's always pushing against the other side over the whole length.
Yeah.
So it doesn't pull apart.
And it's also important to get when you do your cutting, make sure you do a good job cutting, so that it's actually a tiny bit pressed up against both of the edges. So it kind of like has to like show.
So you don't get this.
That
Yeah.
one is,
You don't get the gap between exactly, the ring and the core.
but yeah.
Well, we had that on the button.
Yeah, you can see if you look on the inside of this one, you can see where the Nomex has pulled away from the ring.
Yeah.
Kind of like this one too.
Just a hair.
Yeah.
That was exaggerated.
So, excellent. So we have the core wrapped all the way around. We have the squish joint. We have it in there. It's happy. Now we have to do another layer of adhesive film, and this time you're aligning it to a different ring, a different edge. This 15 thousandths right there. And you do the same process again. You don't put strips down this time, but you just cover this whole thing. And you go through and use the heat gun, put it down, and then you do the same thing with the last sheet of carbon fiber, and it's the same process. You're keep going it, you get it down with your hands. And then the last step of this whole process is the taping process.
Up on top right.
Wow. This is shrink tape, 1 inch, 100 yards, perforated. So this stuff has a negative CTE is what it is, which means it shrinks when it heats up, which is the opposite of most materials, obviously, right? So that means that when you have this thing wrapped around something a bunch of times, it squeezes like a boa constrictor down on it and applies the pressure that composites absolutely need when they're curing. So
You can do that a bunch of different ways. This is one way.
this is one way to do it. You guys will probably do a vacuum bag, and you guys will probably do a bladder. So maybe this doesn't apply that much to you guys.
Maybe.
But for anybody that's doing, vacuum bag for the rest for the rest of this. And so the amount of overlap from one wrap to the next is important. How much you have of it determines how hard it's going to squeeze down, and also how tight you pull when you're putting it down the first time. It's called the pretension, that matters too.
Is that a special type of it, or like just general shrink
tape is good.
No, this is a specific bought from ACP.
Yeah,
This isn't regular tape.
it's on the.
Well, no, I mean like,
Oh.
cause I know you can get the shrink tape that are actually in the tubes, like in the tube shape already, and just
Right.
also just put it over and then go. I just was worried about them shrinking too much when you heat it up in the oven and just tearing itself apart or something like that.
The core will buckle. So if you squeeze too hard on this, you'll compression fail the core. So that tube might be a great idea. I don't know if they come out with the right diameter. It might be a bad idea. It's the testing you guys have to do.
That's probably what happened to this too. Is it was overly done and it wrinkled itself.
But the point being that we're not gonna, it's not no to that product. You have to use this. No, it's just you have to do the testing and try things. So this stuff is perforated, which means it has little holes in it so the glue can escape. We'll talk about that later. But you should use this style. And we have 5 rolls of it already. So the putting the tape on process. So you cut off this little brown bit. And then on this ring, which is supposed to be up against this, you have one person hold it and you get it at the tiniest bit of an angle, the angle you're gonna wrap, and you blue tape it down, and you blue tape the edge of it so it sticks down. You really want this to hold on, so if that lets go, it's not good. Although it doesn't unravel the whole thing, it's important. So you put that down, and then one person turns it. One person
On
turns
that,
it.
really quick. It comes off because when it shrinks, it pulls really hard, and it almost always comes off. It's really hard to get it to stay on, so just keep the shit out of it.
Yes. So one person's holding the roll like this as the thing is spinning, right? One person's doing the actual spinning of it, and then there's one more person who.
I think just 2 people. It's the spinning and one person is, you need to control the angle and the,
Right, overlap.
pay attention to the overlap.
So I always did the taping, it was always me that did it. And so you just want to make sure that when it comes around, that your overlap is a consistent amount, and I do 50%. So for any given point on the rocket, there's 2 layers of tape crushing it. And if you do too less, or you have a gap, you have to scoot back and do it again, do it right, do it as evenly as you possibly can, and eventually you get really good at it. And this is a tape winder, is what we keep mentioning. This is a tape winder. If we had a machine that did this perfectly every time, that'd be really nice. So you go around and you go the entire length of the rocket, all the way down, double sheet, double sheet, double sheet, double sheet, double sheet, comes all the way to the end, and then you cut it off and you do the same, tape it down with the blue tape at the other end. And that's the package. That's the thing that's going to go in the oven. So we have little stops in the oven that are little aluminum holders. So you can put this thing so it doesn't rest on the carbon fiber while it's curing. So you put it down, you put the 2 aluminum holders so it holds it up off the bottom. And we always wrapped what we call the diaper, which is a little bit of this material, this is high temp material. And we just taped it on there so that if anything dripped off of it, it didn't drip into the oven. It just dripped into the baggie and then threw away the diaper. And so we just use the same blue tape and just put a little bit of that. It's not very expensive, but it's nothing crazy, you don't need that much.
One of the shitty parts of this method is that because of the perforation, you get resin that comes out, and then it expands over the hole, and then it cures. So a lot of it sticks. For the most part, sometimes it's really bad, sometimes it's not that bad, and I'm not entirely sure why, but you just gotta kind of, it's time to peeling it off, and you'll see all the little pieces pop off. It comes off.
So
and
it
then
doesn't easily come.
not always, sometimes.
And sometimes you can get it so you when you get a sticker and you can pull off like half the rocket's worth and then it like tears at the wrong angle again and you're like, dang it, and you gotta get back in the fingernail and get after it. So this is just that we got lazy, we didn't peel it off. This is actually a great thing. Why don't we pass this around? Those little yellow bubbles are the glue coming through and blooming, and everybody can try to peel it off. It doesn't matter.
Can you talk about the pretension a little bit more? Like,
Yeah.
Was there did you find a magic?
It wasn't that we did a testing on pretension versus a couple different times. It was just that I always did the pretension roughly the same, which is that I squeezed it a little bit in my hands and fought the person who was turning it. And so we had like a little system where I did it every single time we laid up something, I did it. And I would just like squeeze it just a tiny bit with dry fingers. And so I can just add a constant tension the entire length of it and then glue it down. So that's why I keep saying the tape winder is a great tool that this team could have. The sleeve is another option. Do the testing on it if you think it's that good. I don't know what the outside diameter is. The inside is 6 inches, so the outside is not common.
Yeah, I don't know exactly what size it came in, but it came in like pretty much 1 or 2 inch intervals.
Gotcha.
So I don't remember exactly.
Right. It might be that you know.
I bet you can tell the supplier the diameter you have, and they'll tell you which
Excellent. So then you take the diaper on the outside of the thing, you put it on its little stands, you put it in the oven, you turn on the oven, you put it on its rate. They know how to use the oven, so they can show you how to do it. It's got a controller on the side of it, and it's got 2 plugs. And so whenever they need to do the baking, you guys have to show them. You plug in the two different ports, 2 different 110 volt systems, because we didn't want to use 240 or 480 because it's dangerous, and we didn't want to wire for it and care about the mulch. We talked about it because it's hurt. So don't forget that when on the wall outlets there's a number on them, and that's the circuit they're on. And if you plug in both into the same circuit, it'll break the circuit breaker, which is the whole point of why we use 2. So 2 different circuits, they have a number on them and stuff.
Were you saying something about something after the tape is off? Is there any process?
So if you do something like the call plate, it works really nicely because
It doesn't let the stuff come.
that doesn't happen.
It doesn't glue itself to it.
Yeah. You can just lightly sand it. You don't want to. You want to make sure you don't sand to the fibers.
They fray. You can sand it though. I mean, just don't get crazy with it. Just lightly. So.
I heard you say something about spraying coats on over the top of it after it was done. How did that turn out?
We have all the test pieces here, so you can see all the different ones. This is a lot of coats. I forget. Careful the ends where we use the sheet splitters. And then the kind you don't feel a lot. Oh, this is perfect. Oh, this is a call plate, no call plate. This is with release film in between. Oh, where are they? Here they are. This is this one is. This is 7 layers of paint.
Just clear coat.
So there is testing we did. You have to look through and find the things and look up the pieces we did. Honestly, truthfully, the way that like manufacturers do carbon fiber is that they sand the shit out of it and then they like put thick coats down. So when they want something to look good, and like Cunning Seg's doing their things, watch Cunning Seg's videos. The auto manufacturer, they make like super cars. They're out there. They have a fucking army sanding these things until they turn gray. They clean them off and they do like a hardcore thick coat on them, and they look shiny. So it could be that the real strategy on getting this surface finish right away, even on a 14-inch, is a better finishing method. And I'm sure that one exists, and I'm sure you can make it look good. The question is, can you make it lightweight also?
Yeah. There's a video of a 14-year-old doing a pro job on like 4-inch diameter carbon fiber off it with a playing card. With some hot,
Like
weight,
speed
and
round.
then spin and drag, and it works. And he shows it off afterwards with a perfect cylinder, perfect uniform coating.
Right.
You little kid.
And try it, but don't keep in mind, high performance and stuff. And when it goes through the air at 1,000 miles an hour or whatever, it gets wicked hot. So there's
So
that.
the last 2 things I want to ask are, and you can cover this one in a second, but you said something about a fitting on the oven. Like, what do we need to know about the oven? And 2, is there documentation on the 3D printing of the ring?
Oh, there's documentation on every single thing. Yes.
You
Because
just
I
have
would much rather 3D print the rings than
You can't 3D print these ones.
no.
These are really strong. These aren't that strong.
Well, I mean, you can't. You just have to use the right material. This material didn't work. It's too soft and it melted. If you found something like a super hard resin that worked at high temperature, probably.
This was the highest temperature stuff they have, and plastics don't go at high temperature. And I looked up all the plastics I could find for the 3D print stuff. The technology has changed, but keep in mind that this is made with a glue gun process or a laser sintering process. It literally was cured using heat, so you can't go that hot. So if you want to 3D print them, do it, but keep in mind that my guess is that these rings will have to stay aluminum, and they're significantly more strong. And also they have helical coils in them, and you put the screw in them to attach it up together.
In the documentation, you said they're 6061 T6.
These ones are.
And we got those made by a shop that's emulated. So the hardest part of getting them made is just asking somebody to do it. And if you ask enough people, someone will do it. And somebody
Shotgun method.
Yeah.
yeah, exactly. That's what we did for everything. And it was all free. We didn't even spend any money. Hardly.
So we bought like the call plate, and we bought some pieces of wood, and bought some PVC and that sort of thing. Home Depot stuff.
I was looking at possibly making them out of an epoxy, and essentially an epoxy filler. So the one thing I was looking at, the only thing I was worried about there with those was a brilliance.
Yeah.
But it's something I'm researching, and I was hoping to do at least a couple tests.
do the test. I would say that in general, even in the aerospace world, this is the solution. They bond in an aluminum thing or a titanium thing, and then they bolt to it, and they go back to carbon fiber. This is aerospace's solution. And keep in mind that it's a metal, which means that you get all the benefits of metal. Like you can put a screw into it and not worry about the threads getting torn out. You put a helical on it. You can machine it to high tolerances. You can do the high temperature stuff. It's really right. It would be better if this was titanium, but titanium is way stronger and heavier. So it's like aluminum, not even magnesium, but aluminum is really kind of where it's at. It also doesn't change the heat treat of the aluminum. So in my opinion, keep in mind the benefits of this. And for 3D printed stuff on like the epoxy resin stuff, for windows and for thin attachment points and for hard points on it, genius, perfect, excellent, do it, for real. That's how you have to do it. And also this stuff it wasn't that it melted, it was that, you see there's part of it that's deformed. We didn't put any support under this when we cured it, and so the shrink tape just bent it and it just thermoplasticed it, and then it cured, essentially bent over. You can see this is extremely strong in your hands. I mean, don't break it, but that's not bad for what it is. You can use it as a hard part too. Also, it's worthwhile to say this while I'm on the other topic. You can't just put a bolt through carbon fiber. It doesn't work. The bolt for sure will instantly crush it, and it doesn't play nice. It just doesn't know how it works. And so you have to bolt into something like an aluminum or metal or whatever it is.
So, normally the way you'll do it, like if you wanted to put something like a camera window in this, you'd want to put like an anchor and cure it with everything all at once, so that you have a hard point in there that you can crush essentially, because you can't tighten anything against the core; it'll just smash.
Was that all the questions that were asked? Yeah. We have before we get there. I think that was like the next step. We were. Well, you put it in the oven and you do the curing process. The curing process takes about like 5 hours, like that. It ramps up in temperature. It holds it at the top temperature for 2 hours, and it ramps back down. The controller takes care of it. You just have to type in what you want. And that oven was the first part of our project.
And that cycle is specific to the material.
Right. Yes.
So depending on what material you have, you may have a different cycle.
But the curing procedure will be included in the documentation with the material you get everything, right?
Absolutely.
Okay.
You didn't even ask for it. Did I give it to you right away?
This one was just, it was like 2 to 5 degrees per minute ramp up to 350, and then 350 for 2 hours, and then it's ramped down. The ramp down is less important, but you don't want to do it too fast because everything will shrink and you can break stuff. So we usually did it for like an hour and a half or two. And the oven doesn't control the ramp down. It's sort of like control the cooling rate. It'll cool pretty fast at first, and then it'll cool drop. And then we like crack the door open, and then you can open the light bulb here, so the door away.
So the reason we built this oven so big was so that it could fit the phone in the car also in there. And anytime that we get like a really large part. So this is like a luxury that no other school has, truly. GFR has one, they bought it. But anyway, so this is, there's 2 latches on the front. This is an arc, by the way. I don't know. There's 2 latches, one here and one there. I think these are 8 style latches. You do have to do a little bit of force, but don't be yanking on this thing to run this opens all the way. So, and then we told someone else just to clear our names. The ground in here is not flat, and we built this in its previous permanent location, which was over there. And so the doors fit perfectly. And then we had to move the permanent location over here. And so now the doors are a little wonky. Not our fault. But we also have little coasters under here that's been taken off. But this, if you just put 3/8 of an inch, half an inch underneath this wheel, then the doors work better. Okay. So put that on there. It's just as heavy as fuck to lift. It's in a steel bucket that has wheels on it, so you can actually roll it around. And we actually built it in part of the machine shop and then wheeled it up here too. So you can move this thing. Although this is where it works with the system, so don't move it. You can't. All right.
You can move it, but don't move it?
Yeah.
Yep, got it.
All right. So. So, in general, for safety things, is that This edge right here is wildly serrated sheet metal, and so if you bend down, you'll open your face on it. So just be real careful with this, please. I tell everyone that. And then this rope is fiberglass wood fire rope, and so if you touch it like that with your fingers, they're gonna get itchy as hell later.
Damn it.
Sure, if you catch it like that, you're burnt.
It's a seal so that when the door shut, the hot air is just piping out.
It still leaks.
Still leaks, but does a pretty damn good job.
Yeah.
There's 5 electric coils. We went to the place where you can buy the coils for your oven, at a home electric oven, and we put them all, 3 of them are together in one circuit, and those 2 are in the other circuit. There's 2 circuit breakers back here, so you can turn off the whole system or unplug it, and you're safe. It's all professionally wired with Romex along the back outside of the thing, underneath that sheet metal box that's along the back of it. So don't get in there unless you're about to do some serious repairs, and unplug first. Okay, so the first thing is that initially before we built this stand in here, we used that as our stand. So you can use that. It's not that strong, so don't put too heavy stuff on it, but you can use that. You can basically put stuff anywhere in here, because it's not that important that the temperature is exactly right. And everyone says it is, but we did the testing, and it wasn't, so fuck it. So you put stuff anywhere. We put stuff on top of this just because it was easier, it didn't matter. This line here is the vacuum line. So you can see on the outside, over there, everyone might want to look at it, there's a tiny cone thing attached to a square. That's called a Venturi pump. And the reason we do that, and the way we do that, is you plug in high pressure line, the 90 psi line, and it goes through a Venturi and it pulls on the negative side, so that you put high pressure into it and you get vacuum out of it, which is really awesome. Really useful. It needs some more fittings, and this end doesn't have its fitting. You know what I'm talking about? And so there's a fitting that goes in here that attaches to a thing that looks like a hockey puck, and you put one end of the hockey puck inside the vacuum bag, and then you pierce the bag and you click it to it, and it seals across the bag. And so get the fitting. Look at what you have, and it'll be obvious what you need.
This is for vacuum bagging type curing though, so what we just demonstrated was spring tape instead of that.
That's silicone hose, so you can leave it in there when you're curing, and you don't need to pull that out or anything else. It's missing a grommet on that side now, which I'm kind of disappointed about, because it looks like hell. So if you guys would replace the grommet, if you guys ever get a wild on this side, if you guys are ever interested. So that'll provide the vacuum, all the vacuum you need to do in a bag, if you need to do that. You put the thing in here, you shut the doors, you turn it on, it starts clicking away, and it's a bang bang controller. It turns on the heaters, turns them off when it's too low, turns them on, turns them off. And it takes care of the ramp up and the holds for the whole time. And then when it gets to the end, it turns them off. So what that means is that the ramp down isn't controlled. So it's essentially like turning off your oven at home. It just kind of coasts. But it's not very fast since there's a lot of thermal mass and it's a lot of air and whatever else. So eventually,
not necessarily. I showed Leslie knows the lowdown on the oven controller, the interface over here. I don't know if you want to just teach everyone else. I mean, it's pretty intuitive.
if you can run a home oven, you can run that oven.
Yeah.
Also, in general, Sam's not laying on this very hard. You can't tell. These doors, this is a home built thing out of sheet metal, and inside the middle there's mineral wool, and this is really thin sheet. Right? So these doors aren't wicked strong. So don't lean on them.
What were the holders you were talking about so the carbon fiber is not sitting right on the...
Is there anything underneath?
You can just jerry rig it.
Alright, just
You just
jerry
need to
Just
keep it.
anything,
It just needs
any
a
kind of a
spacer.
block?
We had 2 pieces of aluminum that had an arch machined in them, so we just put them underneath. They got taken by somebody, I guess. It doesn't matter, just anything. Make sure it's aluminum, make sure you take everything out. Also, pre-bake the oven before you use it. Take it to 350, take it along it's secure, and take it back down. And use some other thermometer measurement tool to make sure the oven's going to do what you want when you put a lot of effort into it. Because when you arrive here at 8 a.m. and by 2 in the afternoon, when you finally get in there and then you realize the oven doesn't work, you're going to be wicked upset.
Because everything is time sensitive.
You can't once you do it, once the egg's in the oven, it's like once it's there, it's over. If you can't bake it right then,
So
it's over. You can't put it back in the freezer. We tried that. It will peel itself apart and get unhappy, and you can't bake it afterwards. So you got to bake it right to finish.
these are the thermocouples for the controller, and so the closer you can get this to your part, theoretically the better. But like I said, it doesn't. The material spec will say that it should be even temperature over the whole thing, but we found it doesn't really matter.
Talking about vacuuming, do you guys actually ever get an actual true blown vacuum pump to get yourself down to as close to?
This will get you really close.
Okay.
And then I have used vacuum pumps, and we did use them, and it died on us because the ones that you get are usually not for high vacuum pressure, low volumetric movement. They're for like pulling air. They're not for sitting there holding a vacuum against tight. So we actually burned one out using this, and it's in the control log, or the design log, to see what we had to us. But there's no benefit to going something other than this. I even used this when I went to work after this and broke another vacuum pump at my work, because this is like a magic device that costs like $30 and works perfectly every time and never fails. It's
The
like,
biggest problem I have is the battery leaking.
yeah. Yeah, that's the next, I guess, part of the saga, is that one time we laid up and we used the vacuum materials that the people that own the oven told us to use, because they're an aerospace company and we just believed them, and we plugged all of our stuff in, and the vacuum lines melted, and our part was completely ruined. And now it's on the
normal
phone
with our body.
Yeah, it's still there. But the point being that it is a 350-degree oven, and you cannot use anything that's not 350 degrees in it. Kind of like end of discussion. That's it.
Yeah, everything is convection free.
That's silicone blue hosing
And
for
tape.
vacuum lines, and the tape is the blue vacuum hosing. You can't use painter's tape, whatever else. I mean, you can, but it's gonna turn black and bullshit. So, once again, don't forget. And then when we were finished, we would have these on the whole time just to suck out, because there is vapors that are coming off things. And it's not that it's toxic per se, it just kind of stinks a little bit. So we used to turn them all on, and then we would go outside the room, and we would check on it.
It's for sure toxic.
Yeah, but
There's just not that much of it, so it's okay.
we would check on this all the time. So the point is that if you burn down the building, like it's a big deal. And that the reason that this is here is because we convinced Jerry that not only we're going to make this as easy to use as a conventional oven and as safe as a conventional oven, but the people that we're going to use this into the future, we're going to use it correctly. Seriously, that's what I had to convince them sitting there. So that means you can't go putting questionable stuff that you don't know what it is, or wood stuff or whatever in here. This is not a free-forming oven. This is, if you smoke out the building, this thing gets taken away. Or if you catch a building on fire, it's a big deal. So don't fuck it up. Excellent. Sorry, I didn't mean to say it so many times. But also, everything is sharp, so careful.
The hot surface signs are generally in the hottest.
Yeah. Yeah. So the one you're leaning against with your chest, that line right there is by far the hottest line. So when the oven's on, it's hot on the outside. Although if you touch it, you're just gonna burn yourself. So you'll learn.
It's not burning. It's really not that hot.
You all the way cut the-
I only touched it once. That's the hottest part. If you knew the construction of the oven with the insulation, you know why that was the hottest part. This room will get hotter, and the air conditioner will turn on in this room.
Yeah, it really screws into
It's pretty funny, but it's not.
So what were you saying about the ramp down?
Yeah, ramp down. So it was one of those things where we always had a fluke measurement tool, so we could always see what temperature it was in here. And then it was just like we ramped it down kind of manually and kind of like
Crack the door and
Exactly. You can crack the door because these gates can open. They can just be hung on like this, so the door can be like partially open like this, and so it leaks air for a while. And so it goes from 350 and then it gets to 275 and it starts to slow down its ramp, and then you put it here and let this thing suck out all the air, and then eventually you just go like this and let this stand open, and then it gets cooler, and then you go all the way open, you open both doors, and you have the sucker right in there, and then you wait an hour and a half, and eventually the thing's done.
It's supposed to ramp down similar to the ramp up, so you want like 3 degrees per minute ramp down. And the controller, you don't have to use the fluke anymore. The controller displays the temperature real time. So you just pay attention to the temperature. You just roughly try and get 3 degrees a minute.
Don't get
It's not that hard.
Don't get antsy. Wait the 2 hours or whatever it is, the hour and a half. And then also remember that when you pull that thing out, it doesn't cool down. Just because the air cools down doesn't mean it cools down. And I have burned myself. So the aluminum also dumps a lot of heat in your hands real fast. So like you reach down and grab it, like it burns it really bad. I learned all those lessons. Okay, so after you pull it out, now you have a thing that's cool. You have an oven that's cool. You have the door shut. You're done with that. Now you pull it back over here, and now the impossible part is how to get off the molds. And so we built these things to help us with this process. There's a bunch of these. We laser cut these on that machine over there. There's like 20 of them in here. And if you put them on the ground, and then you put this in it, you notice that it just fits. But if there was this ring down there, it would be pushing up against the surface here. Everyone can see that?
Mhm.
Explanation. So now you can stack a bunch of these, and you can essentially push down really hard on this, like put a piece of wood across as a 2x4 or a piece of aluminum and a piece of 2x4, and hit it with a hammer, and you push down on this, and the rocket will slide up. And so then you can keep stacking these things. Put that one on top of that one. Do you guys see where I'm going with this?
Mm-hmm.
And eventually you can get the thing off. You can put a couple at a time and kind of pan it through, so you can get the thing off. And that's the best way we found how to do it. And then
Best
the
way.
Specifically hitting the inside, not the whole thing.
Right. You hit the.
Yes.
You need to get the tool off of it.
Right.
The best way to do it would be to not have to do that.
Yeah. Another thing I would add to your guys' list. I think I already added to your list.
Just
The
don't,
mold release system.
Mold release system. Both. Yeah.
And also, so you guys are gonna do your design, and it's a hunky dory that you want to lay up on the inside. Don't forget that you're gonna have to get that thing out of there, and don't forget it's gonna be a nightmare because when it cures, it's gonna expand to 350 degrees. The aluminum's gonna grow by a ton, and it's gonna cure hard at 350 degrees. And then the tool's gonna shrink down on the outside of it, and the thing is wicked strong, and it's gonna hold it right there. And now you have something that's crushing it with the strength of aluminum, and you gotta get it out of its mold. So don't forget to take that into account when you do your everything.
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 When
And
you
then,
do your
so, for example, maybe you have a clamshell mold.
That's kind of what we're thinking.
So, but now you have a line in the mold, and now you have. So there's no easy solution you'll figure out. So that's how we get it off. It's really, truly a nightmare, and it was always Rob and Barrett that did it because they're way stronger than Sam and I. And it was like the kind of thing where sometimes somebody will hold on to this side, and someone will hold on to this side, and they're pulling at each other, the two strongest people in our group, and they're like, it's like a nightmare to get off.
Just get
So-
the mold release right.
Get the mold release right.
I also want to point out again that this is the way that we decided to do it, and there are a million other ways to do this.
Right.
So don't just try and recreate it. Although we did build all the tools and did all the research, so this would certainly be a good direction to go. But just you don't have to do it our way.
Right. And there's some things that we did many iterations on, but some things we didn't do many iterations on. So these rings right here, these are really these are gold. They work so good, they work beautifully, they work excellent. These things right here, they work great. The table works great. All these other things we're talking about work great. We didn't spend any time on the mold release, we just got it to work and then kept using it. So there's some things we didn't spend that much time on, and those are the things that really should be iterated on. Jesus, I've been talking about. Is there anything?
That's kind of start to finish.
Yeah, so you pull it off, and then you do the peeling process of pulling at it, and then you guys are gonna figure out maybe a finishing process and a sanding and water. And you put water into it. Don't forget the water's gonna go in and then stay there, and then eventually gonna come back out through little pores. You can test that yourself. It's really weird. But so don't paint it right after you finish washing it. Let it sit and dry for a day, and then paint it. So you're gonna end up sealing water. Yeah, excellent.
This was, we can talk about post bonding real quick. So we chose to do the bonding during the cure, the glue. It's also super common to do the bonding afterward, but it's very tricky because it sort of involves tight tolerances, which is really hard to do with carbon. And so essentially what you do is you make an interface and you put glue in it and you slide it together and let it cure. But we tried that a couple times and it just wasn't nearly as easy as this. But for things like the nose cone, which might be really hard to tool like this, you may want to look into something like that.
That's the reason that we didn't pull the trigger on that, because that joint is not obvious how to do co-curing, which is when you glue the aluminum to the thing that has the things to it.
And that's how we did the fins.
The fins are glued on.
Actually, they're just glued on.
So you can see this thing here. This looks like a little L bracket with a curve on the side. So you can see some aluminum, made a mold, vacuum bagged it, laid up the 3 layers of carbon fiber, whatever, and then glued it after it had cured. We glued it to this and this. So obviously that doesn't look that hot, and there's probably a better methodology. It's a really hard part to design as far as things go. That's tricky.
The hardest part is making it easy to do.
Really, to get it right, I think. Because look at there's core in between the fin, and there's core over here. So now you have this. What is your mold going to look like?
And just for clarification, they want a fin can too, don't they? Do they want a fixed fin or a fin can?
Both.
Yeah,
I don't know if they can do that.
So the rotating fins on the back, because they now have roll control that are smaller triangle-shaped fins that are about an inch long, and they create enough negative pressure that they created a opposite rotational than was desired.
Right.
And now, if you watch the new video, one of the latest videos, they can control 90-degree orientations of rotation,
Right.
as long as the back fins, that whole unit, spins around like a top.
So they just put a
Like a bearing.
Like a
Right,
bearing.
Yeah.
thrust bearing in there.
That thrust bearing would be a replacement of that.
So the other benefit of the rings is that as long as you make the rings interface with each other, you can sort of build anything in between them.
So thrust bearings in between.
Yeah, so you can put like a
perhaps.
bearing assembly in
Oh
between
yeah,
the rings.
we even did a nose cone separation ring. You can see here that interacts with it. That you see this surface doesn't look at all like the normal wing, except for this side does.
Yeah.
And so in this surface here, these are the little electronic igniter wires, and they're glued in.
The boom ring.
And then you fill this in with the glue and the gunpowder and whatever else, and you can blow it off. But all it needs to have is the ring that's just the same as the matches.
To match.
We also did something else with that. Oh yeah, it was
The motor.
The motor. Oh yeah, the motor. There's two more things. So this one is, you see the holes around the outside? This interacts with this ring, that ring. But you can see how this would slide into this ring. Into this ring. And then is bolt-inable all the way around. So now you have a place where the motor can put all of its thrust into this, and it carries it out these little posts, into their companion posts, into the carbon fiber. And this thing is incredibly lightweight. And we use halo coils and stuff. So that's the other thing. And then one more thing is that there is also a thing called pre-preg fiberglass. It's also probably pre-Kevlar. I haven't dealt with that though. And then it's sort of the same strength, sort of, and you can do enough layers to make the same strength. And this is radio transparent. Everyone just went,
You can paint it black.
And you paint it. And this is not radio transparent because it's conductive. So if you need to do another module that's this big right here and put an antenna on the inside of it, you can just have the same style rings, boom, put a little carbon fiber, pre-graded fiberglass, take it the same methodology, use the same wrapping methodology. But
They were talking about doing the entire nose one out of it.
Yeah, you're right.
because I mean, it is weaker and it is heavier, so it is what it is.
But that may be a compromise for the radio.
Trade-off,
Truly.
yeah.
And whatever you do, if you do a good job of it, will be lighter than what they have now, which is kind of really overbuilt. It's like a tanker. But they kind of just like put a lot of epoxy. It's almost, think of it more like as like a cast with like some fibers in it, but a cast epoxy nose cone. That's how they made it. So it's lasted like 1,000 launches or whatever, 6 launches since they've done it. But it is wildly heavy. I'm not happy.
Thank you guys so much.
Is that everything?
I think so.
So
You
that's
guys
the
are
ones I
gonna
can
you guys
take.
are gonna stay in available for contact and questions. Cool.
Yeah. My nightmare of my like worst nightmare of this project, watching you guys go forward, is to repeat all the same mistakes and run the same lessons that we learned slowly and painfully and come to the end having learned nothing more than we learned. My hope is that you guys can take what we learned and know it already and then make your own mistakes and then teach me. So don't do what I did, do what I didn't do.
So use the documentation also to facilitate that. You can feel free to contact us.
Cool. Wonderful. That's all I can think of for right now. We've got
Thank you guys so
a
much.
lot of steps in between.
Nice to meet you. Good luck.
Yeah, we need to
I'm out.
make
Take it
sure.
easy.
Yeah,